Good morning. Welcome to the JagCorner. I'm Will Thorup, and today we're continuing our work on the 240p test suite. I just realized it's going pretty fast there, so I'll turn that back down. There we go. I'm a little slow getting the word out this morning, so I don't think there's anybody on the stream currently, but hopefully that will change soon. But anyways. Yeah, so we're just going to jump right in it today. There isn't any news that I noticed. I haven't really checked, to be honest. There's been just a lot of people talking on that. I think it's called Hammer of Thunder, that beat 'em up that Phobos just announced a few days ago. Other than that, there hasn't been much going on Atari Age that I've noticed, at least what I'm subscribed to. And I haven't spotted anything on Twitter worth talking about. So today we are just going to keep working on the 240p test suite. If you're there, go ahead and give me a shout out in the chat. If you want to talk about anything Jag related or anything Atari related, or if you want to know a little bit more about me, within reason, right? I'll be here for chatting. So let's get started. So yesterday, we did the, well, let me jump over to that really quick. We did the grid scroll test here. Got that working, and this currently is procedurally generated, so it's pretty fast. It's fairly quick, about a quarter of a second. So today we're going to be doing horizontal and vertical stripes and checkerboard. Probably the backlit zone too. I need to look that one up and see what that test actually is. I'm not familiar with it yet. And we may get into the lag test or the timing and reflex test as well. So let's go ahead and do the horizontal and vertical stripes. I'm going to load up really quick I think I still have it here. Yep. Sega Genesis version of this program, and we're going to look at the horizontal and vertical stripes. So looks like there is, I know you guys can't see this right now. Again, I can't get the Mega Drive mid-NAF to render properly in OBS. So it looks like when I hit A, it strobes every other line. Which we'll need to, so we'll need to create two screen buffers to do that we toggle between. And then it looks like there's a frame counter that goes to 50 or something. So we'll need to look at the 240p code. And it looks like we can pause the frames. I don't understand why that's important. And then they have a resolution change. So it doesn't look like we can switch the direction, which is weird because the test is called horizontal and vertical stripes. Oh, maybe it's a direction. Okay, up toggles between which line the stripe is being drawn on, and left switches between horizontal and vertical. Okay, left and right. Cool. In fact, let's go look at his code. We'll just mimic what he's doing. First, let's create our function that we'll be working in. I think it's called draw stripes. I went in and put all the names for the functions as whoever worked on the Genesis version did. Just add it here in our header file, declare it, and then we will define it in our C file. Like so. I'm going to put this back on to the scroll test, just so that's going, and let's go to code. Sorry. Forgot to switch over there. Just added a declaration, and we are starting our definition for the draw stripes. State while we're here, let's just add it to main.c as well. Like that. Okay. All right. And let's go ahead, go over to the browser. 240p test suite GitHub. Jump over to that really quick. Jump into the Mega Drive, the Genesis, as I called it growing up. And what was it called? Draw Stripes. That's what it's called. Okay, so it looks like he has a just an if statement that tracks loading in the assets, and we can use that to alternate or redraw. Okay, so he just has two variables. I guess I'm assuming the alternate is switching the lines between which line it's drawing, and then redraw is just to redraw the screen. Probably for drawing text, yeah. So down there. So do counter. Oh, no, that's outside of that, so that's interesting. Vertical. Huh. I may take a different approach on this. Check help, A button. And then A just alternates between... Oh, A was the... It's weird because he doesn't even have alternate inside of this if statement. Oh, it's probably just a flag that turns on, so it shifts between them quickly. Yeah, that makes sense. Alternate. If not alternate, press up and down. Okay, and so if alternate isn't running, then it's just switching between them when there's a button press. That's what's going on there. This switches between vertical and horizontal. And right does that too. We can do that, and then we redraw. Okay. So pretty straightforward. The only thing that will take a little bit of work is this text at the beginning, but we'll do that. That'll be the last thing we do. Let's set up the rest of this here really quick. Okay. Let's go back over to code. So we're going to need a redraw. Equals 0. We'll need an alternate equals 0. And we will need a vertical equals 0, like that. And are we going to run a for loop? I don't think we'll be needing a for loop, so I don't think we'll need an integer for that. I am going to pull over this. Our main while loop. Okay, and then, well, let's add in our if statement for if redraw. So if we need to redraw the scene, then we jump into that. I'm going to pull out our exit. Just this. And if not exit, like that. And then we'll be loading our graphics before the while loop and after the while loop. So, but let's get that set up first. Let's declare those graphics. We're going to need, I'm going to load 4 buffers. And these will be 8-bit buffers. And I already have functions for drawing stripes, so it's going to be pretty easy to load those already because we've already done most of the legwork. But we do need 2 buffers, so or 4 buffers. Let's just do this. Let's do screen, stripe, screen, like that, and we're going to make 4 of those. Yeah. And then sprite, I did not spell that correctly, stripe Sprite. Oh, we may not be able to use those. Let's see here. Where are we using those? Oh, we're not using that one. Sprite. Huh. Let's do a search here really quick. I'm a little concerned. Oh no, we're only using it in one place. Good. Okay, so we're fine on that. And we need 4 sprites. Yeah. So we will be using a for loop here. Or maybe not, we'll see. Yes we will. Yeah, I think that's all we're gonna need. So let's get a variable for our loops. And we are first gonna set them all to null for I equals 4 or 0. I does not equal 4. I plus like that. And stripe screen I equals null. Just we're treating those all as pointers, and we're just setting them to null. Sprite like that. Okay, so they're all set to null. We're doing this because we'll be doing a check at the end when we unload everything. So okay. Let's go ahead and set up our sprites. So I have 2 functions up here for drawing every other line, and we can set the orientation and we can invert it. So we just need to do this 4 different times. And I may be able to do it in a for loop. Oh no, we need to build our screens here first. So let's go ahead and do that. Let's run another for loop. This is pretty easy. We just, in fact, we could attach them and do everything if we wanted to right now. So, oh yeah, we can do it all right here. No, I think I'm gonna want to do those outside. Stripe screen equals new screen, like that, and then we go alloc simple screen. Depth is 8, and we're just going to make this 320 by 320. I'm going to do a little bit of math here really quick. 320 times 320. I just want to see. Okay, that takes up 102K a piece. We're doing 4 of those. Okay, so yeah, we're under 500K, so we're fine. Stripe screen I. So that's just gonna do all those. Not gonna worry about clearing those because our draw every other line function here will clear those for us. Yeah, let's just do that for now. And then for each one of our, we'll go in and build our buffers here. And I might be able to put these in a for loop. I haven't thought that far ahead yet. So we're just going to do it manually. So the first one is, it is not inverted and it is horizontal, like that. Yeah, I'm pretty sure I could put this in a for loop. I don't want to think through the math on that right now, though. So then the second one is inverted and still horizontal, and then not inverted and vertical, vertical, inverted. So like that. So yeah, I could use a modulo to get the remainder to build that in the for loop, but I'm not going to worry about that right now. I'm going to do another for loop, though, to attach these to the screen. Excuse me. Stripe sprite. Sprite equals sprite of screen. We just give it our XY coordinates, which are 0, 0, and then the screen that we are turning into a sprite. That's not the correct way to say that technically, but essentially that is what we are doing. And then we attach sprite to display. So stripe sprite I is being attached to the display settings D, and then we'll just get to, we're going to do that at the top layer. Okay, I do want these hide and show graphics. Let's see here. I think we're already hidden before we come into this function, and so we can just run that. What is up with this? Yeah, that wasn't indented properly. There we go. Okay, there's that. So this is just showing all of our display layers 3 through 15. Technically only have to do one, but that's okay. Okay, so that should give us all of our sprites. Let me go ahead and run a make command on that. Just make sure. Looks like I'm missing you. Do that again. Error, stripe screen undeclared. 878. 870. Oh, didn't save my header file. There we go. That should help. 893. I missed something. Oh, did not make these pointers. There we go. It's an array of pointers. Error exit undeclared. Oh yeah, we need an exit variable. Int exit equals 0. There we go. And I'm going to go ahead and load that in virtual jag, just to make sure it isn't crashing. Now we should be seeing something. Pretty sure. It might be crashing because I can't exit for whatever reason. Oh, exit equals 1, huh? Controller check, controller lock. That's fine. Huh. That is strange. We are showing everything here, so that's fine. Oh, we did not set this up. We're not actually drawing to the right place, so I'm surprised it didn't crash. Should have crashed. Oh, whoops. This is 0, 1, 2, 3. There we go. That's going through and attaching everything. Okay, let's give that a try. Oh, not that one. There we go. It's full right now because they are technically transparent. So let's do this. Let's make them all not transparent, and we'll be able to see whatever the last one attached to the screen. We'll be able to see that one. So stripe sprite I invisible equals 1, and then we just make like the, I guess we can make the first one visible. Let's make the first one visible like that. Technically I should just run through my redraw function to make sure everything's set up properly, but that's okay. There it is. Okay, so there's our horizontal lines. So if alternate. Oh no, he had this outside, didn't he? See, I don't know if I want to do this redraw function. Technically, well, we kind of need it. We can just set up some if statements for everything. Yeah, let's go ahead and do that. So let's if what variable do we have? Vertical. If vertical, so if it's vertical, we set our vertical ones are these last two, so 2 and 3. If vertical and yeah, we're going to do our flicker outside. I think that's what he's doing. So this redraw if statement is just for button presses, and then he has an alternate one that just, or another if function for the flicker effect. Yeah. Yeah, so if vertical, then stripe screen. Let's see here. I can simplify this, and I think he's doing this too. He's just, I think he's just checking. Else. Stripe screen 2. Let's just do that. Invisible equals 0. And then 0 and 1, the horizontals are set to 1. Like that. Yeah, that's fine. And then kind of do a similar thing down here in our else statement. Just if it's not, get rid of those line breaks, we don't really need them. So 0 will be visible, and then 2 and 3 will be invisible. We'll just set those to invisible. Yeah, that's fine. So that will swap between vertical and horizontal. So let's go ahead and add our controller input for that. I think, let me just check his code really quick. He's using left and right, up and down. Yeah, I think up and down is just inverting them, and then, yeah, and then left and right is setting vertical. Okay. So if joypad left or right, why did it do that? There we go. Or right, then vertical equals the opposite of vertical, like that, and then redraw is equal to 1. And then we got to make sure we do redraw equal to 0 there. Okay, that should switch between whoops, not screen, sprite. There we go. That and left and right. Why didn't that work? That's strange. For some reason, it left. Oh, exit. There we go. Get rid of that. We don't want to exit the program. Or that part of the program. Alright, so why is it I'm missing something? Or for controller lock, I didn't pull that over. There it is. Need that. It's just flipping between it really fast right now. Forgot a little piece of code I need in each one of my loops. There we go. So we can switch between horizontal and vertical. And then we need to do up, down, just to, let's see here, I think he's, yeah, he's just alternating. So what he's doing here, I kind of want to move it all into the redraw function. I don't know why he does it separately. So what I want to do is just add a int invert equals 0. And then just set up the cases here. If invert, so if it's 1, we want, I'm going to move these outside like that. We want 3 to be visible, or let's do this. So 1, or this is 2 will be invisible, and then 3 will be visible. And then we just do the opposite of that. Like that. And that should give us an invert. So we will be telling it to redraw. So let's do this. Up and down. Like that. And it's not switching our vertical. It's invert. It's just switching our invert. Like that. And then we're redrawing. Okay, cool. That one is set up. And then this one, I'm going to just compact all this. It's okay. It is readable enough. We just do the opposite set. So this was for the vertical, and this one is for not the vertical, so the horizontal. And so if it's inverted, 0, 1, 0, 1, and then this is 2 and 3. It's just setting those to invisible every time. I'm not worried about it. It doesn't take too much processing power to do that. It's very quick. Okay, that should work. So we have left and right, which for some reason our controller lock isn't working now. Wonder what that's about. And then our up and down just switches between the lines. And that's kind of hard to see in the emulator right now. We'll be running this on real hardware here in a bit once we get the rest of the functions set up. But you can see it switching between them. I still don't know why our controller lock isn't working. Huh. Let me make sure. Video test. Yeah, it's switching between it for some reason. It's for some reason down and right work just fine. I think we might need to wrap this in bracket or in parentheses, ellipses, or no, parentheses. Like that. That may solve that problem. So it's going to resolve this first before it does this check. Pretty sure that will solve this problem. Yeah, there we go. Now I can toggle between those and invert them. Okay, cool. So the next thing is the frame counter. The reason why the frame counter is important is... actually, no, I don't know why the frame counter is important, to tell you the truth. Oh, we do need... Let's see here. Alternate up and down. Yeah. So up and down switch between, it inverts the lines. So when it's flickering, when it's in alternate mode, we don't want this to be enabled. So I'm just going to add it here. Let's add it here. And not alternate. So alternate needs to be 0 for that to work. And we can test that really quick just by setting this to 1. Make sure that that's locking the up and down. So we shouldn't be able to invert anything. Yep, it's working. Okay. And then let's see here. We kind of want to just add a function that says if alternate. What this does is it's just inverting invert. Invert like that. So invert equals whatever the opposite is, and it's going through that as fast as possible, which I think is fine. I'm gonna double check his code here because he has this do counter. This do counter variable in his code right here. Oh, he does have a field. Where is he adjusting that? If field is equal to 0, else do counter, there's the counter. Field, if field is equal to... That's interesting that he's even doing that. I don't see the field. Oh, there it is. It's toggling there. Field equals 0, and it's toggling here as well. So it's just going in between those. I just don't understand why we need that technically. Because I don't see any checks on field except for these if statements. Frame. Yeah. He's using it as a check, but we honestly don't need that because as long as we're swapping them each frame, it should be fine. So I'm going to ignore that for now. I may be corrected on that in the future. Oh, let's see here. Frame, he is doing a check for NTSC, or PAL versus NTSC here. Yeah, I don't understand why that's important to even show that, but okay, let's we just need to add some controller input here. So if it's A, I believe it's A that toggles this on and off. Alternate equals whatever the opposite of alternate is. Get rid of exit. And this needs to have redraw equals 1 because we want to do that every frame. So now if we run this, horizontal, we hit A, yeah, it's just going between those. And if I hit left, it switches between horizontal and vertical. Yeah. Sorry if, if you're prone to, here, I'm going to leave it small actually. So I'm going to go back to coding. I'll keep it on the browser. Well, we'll do it in coding. But yeah, that's working. I don't want to leave that up too long. That may bother people's eyesight. Move this down below this right here. Okay. Okay, so we have that. Seemed like there was one more thing in this. Let me go check really quick. Oh yeah, the frames. Yeah, I just don't understand why that frame counter is important. Well, I guess we'll add it anyways. So we're just going to do this locally. So frame counter text box, frame counter text box equals, and we need a new text box. Let me grab that here really quick. New text box. It's kind of long. New text box. Let's do frame. What did they put? I can't remember what they write. Frame, colon, and then the frame number. Frame, colon, and then frame number like that. Yep. Box width. Let's just do 128. That should be 128 pixels. That should be good enough. I believe we can do 10 pixels high. Font. It's probably just font. Padding 0. Display is settings, display, position, it's about 200, or sorry, 16 by 200, and the display layer, this will be on 15, and we're going to switch these to 14, like that. And we do not need a drop shadow like that. I think that should just attach it to the screen if I remember correctly. I didn't want to load that. Let's go take a look. Video. Pretty sure, because that's all built in now. New font, new text box. So mallocks it for, goes in, writes it, reset the box height for the screen. Yeah, that's fine. New screen. Yep, and we load the sprite. And if D isn't null, it attaches it, so we should be seeing it. Oh, we should probably make it not transparent. So frame, counter, text box, sprite, trans equals 0. So it's not transparent. Oh, we need to update our count line, update text box, draw text box at once. I think that's what we need to do. But I wrote another function. I can't remember what it is. Let's see if we can find it here really quick. Update line. I think that's what we want. Should probably move that into my text engine function. So if I do this, I think this will do everything. It'll draw the box. We haven't even typed out the text yet. We haven't filled the pixel buffer inside of our screen that's inside of our text box function or text box structure. Font. I can't remember everything here. It's been too long. Here, let me just do this really quick. Just going to copy and paste another instance of this and then update its settings. Font. This is this. Text. I think this is a new position. If I remember correctly, let's go take a look. Yeah, XY position and then the color. So we're not updating the text, but we will be using this. Yeah, we'll just be using this. I wonder if I have a check for update line. What was I even using this for? I don't even remember. Oh, I was using it for the overscan test, I'm pretty sure. So I just wanted to see if color's null, what it does. Oh, it's just switching a pointer, so that doesn't take too much time. So we'll make this white like that. That should video. Yeah, there it is. In fact, we can make this, I think we can make this shorter. Let's double check that really quick. I can never remember the valid values for the width of screen buffers. I have to go in and check that. So if we go to screen.h, it'll show us all the valid values we can put in there. So we may be fine with like something like 64. Right now it's pretty wide. So half that. Go take a look. Make sure that that's enough. Yeah, that'll be enough. In fact, I may be able, if there is, yeah, so 56 or even 48. So let's drop this down to 56 for now. That'll be fine, and we'll be updating those two values. So does he have, go back over to the browser here really quick. His count, he just has a count variable. So I'm actually just going to copy his do counter, and we will rewrite that. Let's do it here. Do counter. This is why I've been kind of just rewriting it. He's using actual tabs in all of his code. I want that up here. Wish there was a quick way I could get rid of all this, but there isn't. And I've never, this is the first time I've ever seen if statements without brackets or without curly braces or curly brackets. So it's got me a little unnerved. I'm pretty sure they work in the removers library, but I like to go in and just add the brackets. it does add an extra line, but for readability, I like it. Okay, so he has a count variable. Let's go ahead and count equals 0, and he also has a int do count counter equals 0, like that. Count. If I think I have a settings equals and settings pal ntsc equals 0 for pal, if I remember correctly. Let's see if I have that written down. I do not have that written down. Let's see if I have it written down in here. Pal, so check pal is 0 and TSC is 1. So yeah, we're good. So if pal and TSC is equal to 0 there, else this is NTSC, this is pal, like that. That's fine. And then I think he's just updating the text here. Yeah, I think this is where he's updating it. And I think we have this simplified here on the Jag to just one line. I just have to do well, let's see here. Update line. We're gonna have to, I might be able to get away with this. Let's give it a try. Frame. Percentage D. Oh no, yeah, I'm gonna have to do this manually, so never mind. We won't be able to do that with one line. Let's see here. I gotta remember my C functions. Darn it, I can't remember. Is it string? It might be string copy. Let me, oh, sorry, you guys are still in the browser. That's okay, we're coming back over to the browser. And it disappeared. I don't know why it disappeared. It does that sometimes. Let's see if I can get it. There we go. That should work. Okay, C code string functions. Let's just look that up really quick. See if we can get a list. String length finds out the length. Just lowercase, uppercase, appends one string. Don't want that. String compare. String set. It sets all characters of string to a given character. No. Where are you? Compare. It copies first n characters of one string to another. So that's the one we want. strn C code. strn copy. Okay, so the destination, source characters, and how many it's copying over. Why it can't just read how many? Oh, it's if you're popping in another buffer. I think that's what it's looking for. So destination, source, and then how many from the source. So let's hop over there. Back to our code. So right here, strn copy. Our destination is frame counter text box text plus, and I think I just put the numbers, so 0, 1, 2, 3, 4, 5, 6, like that. So 6, so at position 6, we want to copy in, oh, I need to convert. That's okay, we can do that here. So int new number, nope, this is a character. Character is 2 characters long. Yeah, let's make it 3. Just for our null at the end, our null terminator in this case. And then I have a way of turning, I think it's this one right here, buffer, value, and base. So the buffer is new number, the value is count, and the base is 10. We want it to base 10, and then we just do new number, and we just want 2 from that. That should be fine. That should work. But we do need to update. I have a function in here called update text box. So update text box equals, or we just send it our frame counter text box, and that should just update it. Let's see if that works. Oh, our do counter is not activating, so right now there isn't a value. I'm gonna check quickly how he's doing that. I think it's B button. Let's see if we can find it. C button, where are you? Do counter, that's alternate. Trying to find which button he's pressing. So it's not A button, it's not up or down, left or right, C button. Oh, B button, there we go. B button, do counter. Okay, we're just inverting. So I don't know why he doesn't keep his buttons organized, but we're gonna do that here. And this is do counter, like that. There we go. So B is the button we need to press. Oh, I do need the controller lock right there. Okay. Okay, there's our frame counter. So we're good there. And I think we can actually drop, we can make this, let's see here. No, we're going to leave that at 10 pixels. We can drop this down to 48, and I think we'll be fine. Yeah, there we go. Oh, there's our frame counter. And kind of want to make it so we toggle the visibility of that as well. So we're going to make it invisible to begin with. Visible. And when they hit B, down here, it is we'll just invert that like that. So if we come here, should, yeah, there we go. It's still showing up when we first when we first make it, oh, I gotta set that to 1. There we go. There we go. That should be set. Now, let me check his code one more time. Do counter. Just seeing if there's another if statement that is taking do counter into consideration, and I'm not seeing it. So it's literally just a frame counter for some reason. So not sure what's going on. He's not doing any comparisons with field to make sure the frames are synced up with this field variable, so I'm not sure why he's doing that. Yeah, it seems a little silly to me, but there's probably a reason for it. I'm going to assume there's a reason for it. We have it. I'm just going to double check everything here. I think we're good to go, though. So A goes between that. Why is our frame still showing up? That shouldn't be showing up. The frame counter should be invisible equals 1. Yeah, should be invisible. We're only setting the visibility again down here, but that's only if B button is pressed. Oh, maybe this is setting it to visible again, so let's drop it down there. That may be what's going on. There we go. So now that's functioning properly. I think that's updating fast enough. Okay, so there's our flicker there, and we can switch it between horizontal and vertical, and it works when it's not flickering, and we can invert it on both the vertical and the horizontal. So we should be good there. We're going to quickly write our code to unload everything. So we need to unload our 4 screen buffers and sprites and our text box. So let's do our text box first. I think I just have that set up. This is frame counter text box equals free text box, and then we pass it through again like that. That should do the trick there. So that's our text box freed up, and then we need to run a few for loops here. I does not equal 4. I technically should be using less than here. I think that's technically faster. I like using does not though. I plus plus. Okay, so first thing we need to do, well actually first thing we need to do is hide our displays, our display layers. Let's do that first. And then we need to make everything invisible. Actually, I'm going to go backwards on this. I'm going to go backwards, and there's a trick to this. Does not equal 0. I think I just put the plus plus on this side, and what it does is it actually decreases it. Does the check, then decreases it. So it will do 0 once, if I remember right. The reason why I want to do this is I want to free those pointers in order, in backwards order, basically. I've never done this before, but I think this will work. I'm trying out something new. So screen or stripe sprite I invisible equals 1, and then we go detach sprite from display, stripe sprite Y like that, and then we free it. Free. And then we need to free our screens, screen data like that, and then our screens. That may be all we need to do. Let's see if that crashes. I'm guessing it's probably going to crash. I've never done that before, so. Yeah, it didn't like something. Here, let's do a quick test. Does not equal 4. Well, that's seems to be working fine there. Yeah, that's fine. Yeah, that's working fine. Okay, I think we're done with that. Let's do the checkerboard. I will be jumping off stream here at 8 o'clock sharp. I have some work I have to do earlier this morning, so. Let's go ahead and do that. Our next one is called draw checkerboard. Let's add our declaration for our function. Getting rid of some line breaks here that don't need to be there. Okay. Checkerboard. This is a void function. And we will now define it at the bottom of this source file, like that. Okay. This one, I imagine, is probably going to be pretty similar. Let me jump into the Mega Drive version here really quick. Check out the checkerboard. Check out the checkerboard. So A, again, does the flicker. And B gives us our frame count. C just changes the resolution. I think it's kind of hard to tell here. Can I make this bigger? It's not letting me make it bigger. I think it's inverting. Yeah, and left and right do anything. So up and down just inverts things. So I'm actually going to bring in everything here in our Stripe test, and we just need to remove, it's only going to be 2 buffers rather than 3 or 4. So, and we're going to rename it. So screen, this is checker screen, we'll just call it that. And there are 2 of those for our inverted and non-inverted, and same thing for our sprite. So this one's going to go pretty fast. I think getting this set up, we just need to swap out all of our stripe screens for checker screens right here. I'm going to do that manually. And the rest of them are down there at the bottom. So make sure we get those like that. And then our sprites. Sprite. Like that. Sprite, where are you? There you go. We're not going to need all these, but I'm going to keep them there anyways. We do not need this vertical check, And these need to be set to 2. All of our for loops need to be set to 2. 2. This is 2. I think that's it for our for loops. So we should be good on those. Okay, we got rid of vertical, and so we need to check all of our if statements that have vertical. Oh, we need, before we do that, let's update these. We do have a function for drawing our checkerboard. Do that here really quick. Why didn't I replace those? Oh, whoops. It's looking at the wrong function. Uh-oh. Did I screw things up? Nope, that's fine. Okay, I just got to make sure I'm down here. That was close. Okay, checkered screen. And this is the first one. And it is... we can actually move this. Nah, I'm going to leave it out. Just to keep it consistent with the striped function. We can technically put this inside of our for loop because there's just 2 of them. But we're gonna leave it outside. Okay, so that's set up. We're not worried about vertical anymore. So we can get rid of this if-else statement. Tab that over, and we aren't worried about most of these. In fact, we can get this, and I think we're just going to need an if-else statement. If it's inverted, then 0, 1, then yeah, 1 is visible, and we just do the opposite down here. Okay, that's done. We have our PAL and TSC, and we're updating that, so that's fine. I'm glad we kept that local. Okay, we do not need left and right, I believe. Anything, yeah, so we can get rid of that because we don't have vertical anymore. We have that. Alternates turned on. We may be good to go. That may be it. Let's see what it says. Oops. Oh, belt. I was expecting something there. Oh, we need to add the function to our state machine. We haven't done that yet. So do that really quick. Go to main and add it to our state machine here. Checkerboard. So there's that. So if I hit A, it'll flicker it, and it looks like that's working. Got our frame counter, and then up should invert it, and it looks like it's doing that. It looks like it's inverting. Let's go into it a few times, make sure we don't crash. Looks fine. Looks like we're in business. So, okay, let's test these on real hardware really quick, since I haven't done that yet. Real hardware. Okay, first is our horizontal and vertical stripes. So there's that. We can invert those by hitting up and down, and that looks like that's working correctly. And then vertical. We can do the same, and then we can turn on our flicker test, and I apologize if this bothers your eyes. And then we can switch between horizontal and vertical. And there's our frame counter. We're good on that. Go to checkerboard. we can invert that and tell it to flicker every other frame, and there's our frame counter. So yeah, those are good. Those were easy tests. I'm gonna go check out this backlight test really quick. On the Sega Genesis version, because I have no idea what that is. It looks like it's a dot on the screen, and I can scale it, make it disappear. It's interesting, and we can change the resolution. So yeah, I can move it around, and it does have collision. Okay, this should be fairly easy to do. Looks like it's just doubling its size. So 1 pixel, 2 pixels, 4 pixels, 8 pixels, 16 pixels. So up to a 16 by 16 sprite. So there's a few ways we can do that. There is an actual scale function on the Jag. So if I did a 16 by 16 sprite, we do our largest and then just scale it down. We should be able to do that. Yeah, that should work, right? Right? Yeah, that should work. Okay, so let's do LED zone test. That's what it's called in code. In fact, we'll jump over and check out his code here really quick as well. This is a void function. Go over to our tests, add it. Add a definition, save. And save. Let's go over to his code. Drop shadow test. Gotta find it. LED zone test. I guess I could be looking at their Wikipedia page. It would explain this stuff a little bit more. That would be the smart thing to do, but I'm not too worried about that right now. Oh, so we do need to take NTSC and PAL into account. And I'll have to work on this outside the stream for PAL. I have to hook it up to my CRT. And I'm not capturing that, and so it'd be really boring to do that on stream. B button. Draw float menu. Okay, yeah, that's fine. So the B button, what it does is it turns the sprite off, but it almost looks like it's doing something else. Oh no, it's just not drawing it. If draw equals temp, else temp equals X. Oh, it just moves it off screen. That's interesting. He's not actually hiding it. Okay, so that's not a big deal there. And then change if case, yeah, and so he's just changing the size of the sprite there. Yeah, so this is pretty straightforward. I'm not really gonna look at his code here. I'm just gonna build this myself. Okay, so we will need a we can do this a couple ways. We can do a screen buffer, or I could just do a phrase and fill it. Let's just do a phrase. Equals, or not equals. This is, what do we call this? I don't even know what to call this. Phrase LED data. Let's just call it that, and then we need a sprite called LED sprite, like that. Save that. I will need some things. I'm just going to pull this over just so we have a template to work with. Delete what we don't need. Gosh, we don't really need anything for this one. Get rid of all that. I don't even think we'll need this redraw function. Don't need this counter. We do need the controller input, so I'll leave our exit controller code right there. Okay, let's make, so our phrase, or sorry, not our phrase, LED data, we need to build our graphics data equals malloc size of a unsigned 8-bit integer times by 16 times 16. Yep, because this is going to be an 8-bit sprite. So we allocated that, now we need to set it. There's a quick way we can do that. We could let's just use memset for this. I think that'll be the quickest way. Well, I kind of want to use the do it the quick way, you know, just so I remember how to do that. So we only need to do half the size. So if I does not equal 16 times 16 divided by 2, like that, then I plus plus, I'm gonna hard code that. 16 times 16 divided by 2, 128. So just doing that math beforehand, like that. And I think we can just cast no, we need int data pointer, like that, and this is an unsigned uint 16 equals, we're going to just do it down here, equals LED data, like that, and we make it an unsigned 16-bit integer pointer, like that, and this is a pointer. And now we can go data pointer, the pointer, the data pointer, we advance it, and every time we advance it, we set it equal to 0x0101, which is just the second palette ID in our palette. And that should work there. Hopefully that doesn't crash. We'll find out. There's another way I can do it that's a little bit, well, actually it isn't faster, but okay. And then our sprite, LED sprite equals new sprite, which is 16 pixels wide by 16 pixels tall. We're going to put it at, debating how I want to do the collision on this. Let's do it at 160 to 110. And then the depth is 8, and our buffer is LED data, parentheses, like that. And then we need to attach it to the display. LED sprite at display, our display structure at layer 15. Okay, let's see if that works. Oh, whoops, don't want that. Error, exit undeclared. Exit equals 0. Error, frame counter text box. Undeclared. 1190. Oh, we gotta get rid of this. Our unloading code. There we go. Okay. See if that worked. Oh, haven't added it to my main loop yet, to my state machine. Let's do that. Main. There's that. Video. There it is. There's our sprite. So that worked out just dandy. That worked out dandy. Okay. In fact, we're going to unload the sprite while we're thinking about it, which is pretty easy. We just LED sprite invisible equals 1. Then we detach LED sprite and we free LED sprite, and then we free LED data like that. That's all we need to do for unloading. Okay, so it starts out as 1 pixel, and the way we set that, we need to do LED sprite. We need to tell the Jag that this is a sprite we can scale like that, and then LED sprite. Let's do this and scale. We're going to create a new one. 32 is the native scaling, if I remember correctly. And 1 pixel, this is going to be a little tricky. We may just need to trial and error this. So H scale equals scale, and V scale. V scale. We're going to create a little int scale update equals 0. We're just going to create an if statement up here for if scale update like that. Then we're just going to have it run this. In fact, I'm just going to cut that out, and we're going to run it once as soon as we jump into that loop. Like that. And then, let's see here, he uses button right, so the size. Give me just a second. I'm just seeing how he's doing this. Button up, down, looks like button A, button B. Yeah, he's, no, button B hides it, button A changes the scale. Actually, and sprite state equals 0. Okay, so we're going to set up some states here. So 0 equals 1 pixel, 1 equals 2 pixel, 2 equals 4 pixel, 3 equals 8 pixel, and 4 equals 16 pixel, like that. So that's going to be the states of our sprite that will determine the scale. So I'm actually going to set the scale. See, and this is why I said we're going to have to do some trial and error here. We need to do scale update equals 0, like that. Let's set this. I think it's going to be 4. It's going to give us 1 pixel. I just don't know if that's going to show up good. Oh no, it looks like that's 4 pixels. So 2 should be 1 pixel. which I think makes sense. Backlight test. Oh no, that's 2 pixels. And then scale 1 should give us. So 1, 2. Oh, this may correspond pretty linearly to those values will match, almost match our pixel values. What am I doing? No, audio test, there we go. Oh, it's almost 1 pixel. So this may not work. Let's see here. Scaled, let's try, oh, not that. Scale is 0. Let's give that a try. See, I think this will make it disappear, so this may not work for our test. Yeah. So that's not going to work. So what we're going to do, excuse me. How do I want to do this? We could create 4 different sprites, or 1, 2, 3, 4, 5 different sprites. I'd rather not do that. I'd rather just write our buffer, just update our buffer. So we've mallocked it here, right? And what I'm thinking is we just redraw the buffer according to the size that we want. So instead of this scaled stuff, get rid of all that. In our redraw function, we'll do a switch case. Switch is sprite state. So case 0 break. So for our first case, well, this is case. I'm actually going to create data pointer will reset each time. Actually, technically, I don't need to do that. Let's just do it right here. So it's just, oh no, we do want this to reset each time. So we'll do that in our switch case statement, like that. Okay, case 0. Actually, I'm going to make this case 4 for our full-size sprite. So this one should work right now as it sits, like that. And we can test that by setting this to 4 and running our program. Yeah, I think this should work. Oh no, didn't work. Why didn't you work? Oh, scale update. We're gonna just call this redraw now. Redraw. Redraw. Huh. Why wouldn't that work? This is just a temporary pointer, and that's fine because we're still in our loop, our switch case loop here. LED pointer, that's fine. We are showing it, and that's okay, because it should just be updating. Wonder why that isn't updating. Let's do this really quick. Let's do just case 0. And this is just going to be writing the first pixel. So we're just going to set that to 1 and do that. That should be just the first pixel. Set this to case 0. This isn't important anymore. Oh, it's because it's, well, yeah. we do need to do this once. Let's see here. What we can do is right at the beginning, we wipe it out like this. I wonder if it doesn't like this being here. So if we did this instead, and then we write zeros to it all, like that. Let's give that a try. See what that does. I've never done anything like this before, so. Okay, so it is, I'm pretty sure it is drawing our white pixel at the very beginning, but we want it to go through and draw everything black to begin with. I don't understand why it's not doing that. Let's try putting this on the outside, see if that works. There we go. So we have it drawing black, which is important. I think this is a scope issue. So if I copy this into here, this should give us, here I'm going to just do that. Let's do 2 pixels just to make sure. Why doesn't it like that? Oh, maybe it is saying I'm redeclaring it. Let's see here. Error label 1191. Error. A label can only be part of a statement, and a declaration is not a statement. Oh, it thinks it's part of the label. Am I writing my switch cases correctly? Oh, you guys can't even see the code. Wish somebody would say something. No, I should be better at remembering to switch back to the code. Switch case. Switch case. I'm doing it right. It's just a colon. Expression. Yeah, that's fine. Wonder why it's giving me some trouble with that. That is strange. He's putting a space in between things, but that shouldn't matter. Why is it giving me trouble with that? Huh. I'm not sure why it doesn't like me adding that variable there. That is weird. But whatever. I have it drawing black. I'm just afraid if we do it out here, it's not going to properly reset it. I'm pretty sure that's what's going on. So if I declare it there, what I can do is just do this again. This might work. Yeah. It's a little frustrating. I have to reset that each time. Why isn't it showing up? Huh. Put this down here. I'm not sure why it's complaining about that. Tests. Oh, I'm not worried about any of that. Unused variables, not worried about any of that. Warning, 1191. Assignment makes integer from pointer without a cast. Wait, is there a syntax error here? No, that's fine. I'm going to run this one more time. Warning, 1190, okay. Without a cast. If we did that. There we go. Okay, I think we got it working. I wasn't supposed to. Yeah, we're good now. Okay, cool. And what this does, so when we write it all black, what's happening is it's advancing the address every time, and we have to reset that address, and so we just set it back to the beginning each time. Can we just do that once out here? That would be very useful. That way I don't have to keep typing that out. Nope. We have to set it within the case. Unless I do it out here. Let's give that a try. There we go. Okay, so we need just 1 pixel. Let's test that. Test, backlit zone test. There it is. There's our 1 pixel. Finally. We got it. Okay, and then this is where it gets a little bit trickier. We want to write, let's see if I can do this with math somehow. We want to do 2 pixels, so there's our first. We want to do it 2 by 2, right? So we really just need to write once there and once on the next line down. I don't know if there's an easy. I think I might need a double loop for this to properly do this. Let's go ahead and do it. So let's add another variable to work with here for our double loop. And let's see here. No, I should be able to do this without doing that. Give me just a second. Let me think through this. I should be able to just multiply it by the width. So if we do data pointer equals, so we do the width, so I times half the width, which is 8, then yeah. We may still need that. Maybe. We'll see. Let's see here. I times the width. So it's going to start first pixel there, and then it'll go down to the next one there. Let's see what that looks like. This is case 1, so we'll set it to 1 here to test. I've never drawn sprites like this before, so this is interesting. Okay, we have our first line. We don't have our second line. Why don't we have our second line? I don't think it's actually advancing. It goes through it once, does it once. Oh, this needs to be plus equals. There we go. Let's see what that does. No, I didn't like that. Let's see if it gave us a warning. There's something I'm not doing quite right. 1199. 1199 without a cast. So do we need this? Check that really quick. Okay, it's not complaining about anything. We're still only getting one line. Huh. How do I advance this pointer? Because this should just be advancing it like it normally would. I just don't know if we can do it on a separate line like this. Can I just do... Can I do this plus like that? Because that's essentially the same thing. Well, yeah, I don't think it'll allow me to do an equation on this side. This is why I think I do need a double loop. Basically, we have to advance that pointer 8 times and then move it over. And then write. So if we did another for loop here, so for I, I equals 0, as long as I doesn't equal 8, I plus plus. Data pointer, so we write it first once without advancing, or I guess we could, yeah, we just do that, I suppose. No, we should be able to just do that, and then we advance that pointer, data pointer plus plus. It advances 8 times. Oh, that doesn't work. Let's see here. 2. I mean, this should give us our 4x4 pixels that are white, or 2x2 pixels that are white. Excuse me. This function is so short. Int I equals 0. There we go. See if we got our 2x2 block of pixels. Yeah, so there it is. It's frustrating I can't just advance that pointer by a specific value. Like, why can't I just do plus equals 8 like that? Can I do that? That'd be very useful if I could do that. Problem is I think you have to do it before you set it. Yeah. So it's definitely not working. What's weird is that probably should have been 2 pixels, but... So yeah, that's one way to do it. And this works. I just wish I didn't have to do a double loop. Here, I'm gonna do a quick search here. C code advancing pointer address. Pointers in C. Pointer arithmetics. Increment decrement of a pointer. Got 2 pointer before increment and then increment. Okay, so yeah, that makes sense. We're just setting an address. My goodness. Oh wow, I can't even continue without logging in. Let's see your pointer. P equals A. I know this is kind of messy in terms of coding. So first, the pointer takes precedence over the pointer operator and the over everything. Second, the pointer is the same as if you're not assigning them to anything. The difference is, yeah, so it doesn't look like there's any way to increase a pointer's address by a specific value. You have to use just the plus plus or the minus minus, increment or decrement, rather than one. Oh, here we go. It moves size of t bytes, and that's probably why it does that. So can I cast this character be 1 byte into an int? Incomplete type. Oh, and we wouldn't want to increment it by 8. We would want to increment it by 4. Yes. Instead of 8. I wonder if that's what was causing the problem. We're going to point 2. This may be confusing the first time you meet it, but actually it makes a lot of sense. This is not a special processor feature, but the compiler calculates it during compilation. So when you write pointer +1, the compiler compiles it. Oh, so yeah, I should be able to just do so I should be able to just do +4 like that. Does that work? Hey. This may work. Nope, didn't work. Two. That is valid though. Wonder why it's not actually advancing the pointer. This should give us 4 pixels across, technically. But it's not. It only works with ++. That is crazy. I'm wondering if it spits out a warning here. Let me check. Statement has no effect. Yeah, so you can't. Yeah, it doesn't do anything. Huh. That is surprising that I can't increment. C code meant pointer with a specific value. By specified value. In both your questions, the base pointer constant, so the expression base pointer plus 46 are performed as unsigned integer arithmetic, not as pointer arithmetic. So there is no compensation applied to the size of any object referenced by a pointer to which you subsequently assign the result. However, if you first assign or cast the base pointer value as a pointer, then add something to that, the addend will then be multiplied inherently by the size of the pointer. So the following first two lines. So he casts it. Base pointer, it's just a number. So do I just need to cast it? Because I can do that. That's easy. Changing your definition. With other casts will be formed as pointer arithmetic. So, I've never had to do this before. So if I do plus equals and cast it as a uint, pointer, I don't think this will work. I'm curious, does it complain about it? Makes integer from pointer without a cast. So if I cast this, sorry, I know you guys can't see that. I forgot to switch over. Yeah, it doesn't like that. So yeah, that doesn't work either. Okay, I'm just gonna move on. A little bit frustrating that you can't just advance that address by a certain amount. There's probably a way to do it, but I'm not clever enough to figure it out right now. Okay, but that's okay. Because what we can do now, so we have our 4x4 pixel, now we need, or our 2x2 pixel, now we need our 4x4 pixel. So case 3, and that is going to be, this is 2x2, this is 4x4. We advance the pointer and then write it again. Wait a second. This will give us, yeah, this will give us our 4x4. This won't be right, but I want to see what it does. 2 case 2. What? Oh. Forgot to put apostrophe after that. Okay. Yeah. Yeah, I knew it was going to be offset. So because we only need to advance it 2, pretty sure. Oh no, that didn't work. Let's see here. It's doing 2 pixels. Is it just oh, it might just be just 4. Yeah. Whoa. Whoops. Changed the wrong value. 4. Right there. Huh. Why isn't that right? 6. Let's see here. Oh yeah, it is 6. That makes sense. Because we're writing 2 bytes at a time. Really, 7? Let's see here. We do 0, 1, 2, 3, 4, 5, 6, 7. Huh. That doesn't make sense to me, but we'll go with it. This is right. Okay. And then we need to do that 4 times. . There we go. There's our 4x4 box. And then we need to do our 8x8. 3, 8, 3, maybe? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this should be our 8x8 box. Why is it giving me 1201? Computed is not used. What is not used? 1201. Oh, it's fine. Error, duplicate case value 1216. 12. Oh, there's a duplicate case somewhere. What? Oh, did I copy it twice? That was weird. Yeah, I must have copied it twice. Oh, we need to switch our case to 3. We're almost there. There was a faster way I could do this, but I want to get this figured out, this advancing pointer thing. It's okay, so that didn't work at all. It is that 8 pixels? Yeah, that's 8 pixels across, so we're good there. You just need to bump this a few times. And I'm not even going to try to figure this out in my head. We're just going to trial and error it. Okay, and one more. 5. There it is. There's our 8x8. And then we have our case 4 for 16x16. Okay. Let me remember he's pressing A to change that. So, joypad A. We're not exiting. We are changing sprite if sprite case state plus plus, and then we just need to do a check if sprite state is greater than 4. Let me just wrap it back down. Sprite state equals 0, and then we need to redraw equals 1. Okay, that should allow us to change the size of that sprite, and I need to get off here in just a moment. Yep, there we go. Okay, so we can change that. Let's move stuff around here really quick. Maybe we'll have to skip our collision stuff. Up. Not worried about the controller lock. We just take LED sprite, Y minus minus, down is plus plus, left is X minus minus, and right is X plus plus. Make sure that that's working. Video test, backlight zone. Okay, we can move it. We can change its size like that. Okay, and we need collision. So this is move sprite and then sprite collision like that. if we'll do these independently. If LED sprite X is less than 0, LED sprite X equals 0, like that. We're going to do another thing here. We need to set int sprite width and height equals 0, 1. It's 1 pixel wide and high. Yeah. And we're just going to set this every time. So for case 1, it equals 1. For case 0, it equals 1. For case, it's 2 by 2, so its width and height is 2 pixels. And this is 4. This is 8. And this is 16. And this will just adjust the collision depending on how big the sprite is. And we just need to rewrite this a little bit. So if it goes, we don't need to worry about the left side of the screen or the top of the screen. It's just the right and the bottom side of the screen. So we actually don't need to worry about that. Let's copy and paste this and do the right side of the screen. So if it's greater than, and I'm going to have to come in this and change this for PAL later on. Greater than plus sprite width height. We're going to wrap that in parentheses. And then we set it at, hey, late to stream, we'll be back. We'll watch back the stuff I've missed. Yeah, it's been kind of a, it's good to see you, Matt. It's been kind of a bit of a straightforward day. I don't want to say boring. Things have gone pretty smoothly. So equals 320 minus. I'm finishing up this LED zone test thing. I don't even know what this is used for. I need to look at the Wikipedia to see what this test is actually for. I'm imitating what's in the Sega Genesis version of this, and I'm almost done with that. I was hoping to get this finished by 8, but I'm going to take a few more minutes. Okay, let's test that collision really quick on the X. So this should stop on the left side. Yep. And it should stop on the right as well, like that. And if we change, our sprite size, it bumps it over. For some reason, it's not doing it for, I must have missed one. Oh yeah, right there. 16, there we go. Okay, that'll fix that. Okay, that's the left and right side, and now we need to do the top and bottom. And these are Y's. Y. In fact, I'm just going to go through and swap these all out so I don't miss any. Like that, like that, like that. So if it's less, it will set it back, and then if it's greater than, and see, this is going to be different for NTSC versus PAL. So what we can do, we can do an inline logic statement. So let's just do some parentheses here. If settings PAL NTSC is greater than 0, then if it's greater than 0, it's 1, and so we want it, which is NTSC, we want it to be 240. Otherwise, it's going to be 288 for PAL. Pretty sure. And we do the same thing down here with this. Minus. That should do the trick. That should be all we need. Oh, it doesn't like me doing that, apparently. 2 or 3. I'm not worried about that. Error. Expected identifier 1277. What? Oh, right there. And I messed that up everywhere. Okay. There we go. So if we go to the top, it should stop. Oh, and it did not. Why didn't you stop? LED sprite. That one should definitely be working. Y is less than 0. Set it back to 0. Why isn't that working? Huh. LED sprite. Yeah, that should be working. Less than 10. Am I just not seeing it? Is that the problem? Yeah, I think that's the problem. We just need to set this 10. Double check here again. Okay. Okay, it's working. I just couldn't see it. Okay, we're good. We're good there. So the bottom of the screen should work too, but we may not see that either. Let's see. Oh no, it worked. And it's adjusting. Cool. We're good. There's that corner. There's 16, and we can go all the way down to 1 pixel. Yeah, there we go. We got our collision set up. Okay, we are technically done with this test. There was one other thing, and I don't understand what it's for. Is it just makes the sprite invisible. Let me double check that on the Genesis version again. And again, you won't be able to see this because I can't get the emulator to show up. Okay, yeah, it just makes it invisible for some reason. Okay, so I'll add that here really quick. Pretty easy. Just do that. We're not redrawing, we are locking. We just do LED sprite invisible equals LED sprite invisible. The opposite of that. Now we can toggle that on and off. Oh, whoops. Okay, video, backlight. Now we can toggle that on and off. Cool. And our collision is working. Yep. Uh-oh. Uh-oh. Something happened. Oh, did it get caught? I think it may have gotten caught in that corner. Oh, no, it's fine. Interesting. Thought it got caught. But we should be good now. Yeah. Okay, cool. All right, that's where I'm going to stop today. That is unloading, right? Yeah, that is unloading, so we're good there as well. Yeah, we got that. So a little more work than I was expecting it to be. Just drawing those different, using this new method of drawing the sprite. I'm not used to that. I'm not used to incrementing and decrementing pointers in C. So there are some, seemingly there are some limitations that to that. It's possible I just wasn't doing it right as well. So that's always a possibility as well. These languages are quite verbose. They're quite the way to do things is very deep. You can choose to do things in many different ways, and so memorizing all those different ways of doing things is, for me, basically an impossible task. And so constantly relearning things and learning new things. So anyways, but yeah, thanks for watching. I'll be streaming something next week. I'll be streaming a game. It was Asterite, but I may delay that. So I'll be thinking of some other games to do at some point there. But yeah, again, thanks for watching. I'll be streaming next week, Tuesday morning or Wednesday morning. Don't forget to check out my social media links down in the description and that newsletter on the website. And we'll see you next week. Bye.